So yeah, I'd like to introduce Durrett, cool rhyming name, doing our talk today.
Growing up, it was very cool.
Yeah, I bet. So Brett is the VP of Engineering and Operations at IMVU, which is kind of the pioneer lean startup. It's the company that Eric Rees himself co-founded. And he's going to talk continuous deployment, which is something, as a CTO, it's something I've achieved at my company. Not to the level that he has. We deploy like 3 times a day. You guys are at what, 50?
Up to 50 now.
Yeah, and I can tell you it's hard. It's hard, but it's worth it. And it's pretty amazing what they've accomplished. You have a team of about 50 engineers, and to do that kind of stuff and be that nimble with a team that's big, that's that big is pretty amazing. So he's going to tell us some of the tricks of his trade. And without further ado.
Great, thank you. Thank you. How many people are familiar with continuous deployment? So maybe we'll go the other way. How many people, this is pretty new to them, they don't know much about it at all, but they like pizza and beer? Okay. So one thing I find that when I do this talk, I invariably kind of don't always get the right slides with the right audience, and so there'll be plenty of time for questions afterwards, but hopefully, whether you're an engineer or whether you're in product development or anything else, you can see the value in this and understand it. It doesn't get too deep into technical, so I think it will express the value. My background is actually not in sort of the website. I started off a long time ago doing video games. Back in the 90s, I had a video game company, and one of the people I used to work with is here in the audience. So thank you for coming. This was an industry where basically deploying software is tough because not only do you have a long development time, a couple of years sometimes, and then it gets sent off to a company to manufacture, sometimes put on launch or something. But it's really, really difficult to release. And in contrast, these days, web-based things can be updated instantly. Anyone that has an iPhone or an Android understands that every 10 minutes you have to update all your apps. The world has kind of changed. So for the last 6 years, I've been at IMVU. And over the last 3 years, I've been running all of the technical functions, so engineering and operations. So I've had the benefit of seeing sort of continuous deployment in the company and also understanding how it works from both the engineering side and the operations side, which has to deal with the servers bouncing down if something goes wrong. So a little bit about IMVU. How many people are familiar with IMVU? Okay. So we're a destination site. People go there. It's really about chat and games with avatars. The numbers that you're looking at are from 2010. The people that handle our marketing and PR haven't updated the stuff that I'm allowed to release in public, so I have to use last year's numbers. We primarily, our main product offering has been a website with a Windows download and a Mac download. This year we've started to get into sort of the mobile space a little bit as well. But predominantly it's the Mac and Windows is where our core business is in. We also are very big into user-generated content and virtual goods. So if the avatars that people have, we don't build the content for them, our customers do. We have over 6 million items in our catalog, all built by our customers for our customers. And as a business, we basically sell credits, is what we do, and it allows customers to buy from other customers. So it's a pretty good business. Most importantly, I think that the engineering staff scaling to about 50 people is fairly relevant when we talk about the process that we're about to walk through. So a little bit about how we work as a company. Basically, we build things in very, very small pieces. So we'll develop something incrementally, either a small change to the existing site or maybe a feature, but we'll do a very small, couple hundred lines of code maybe. We check this into a system that runs through a bunch of tests and says, hey, does everything look okay? And if the system says that everything looks okay, it goes out live into production, which at any one time, like the number of people chatting on our site are somewhere between 100 and 150,000 people running on a back end of about, I think, 800 to 900 servers right now. So this change that I just happened to make in my sandbox has gone out to the cluster. This whole process takes about 15 minutes. And just to make things a little bit more exciting, there is no staging cluster and there is no QA involved in this. So it's literally, I'm building something, I check it in, 15 minutes later our customers are experiencing it. So when I explain this to people, I get a kind of a common question. Why would you do something like that? Particularly companies that have experienced pushing out software, building things, and the pain that happens with the release, the people sitting in a room. So I'm going to kind of go into this. I think I've got at least 4 good reasons. I'm going to go through maybe 6 reasons, but I think 4 of them are good, and explain why continuous deployment is actually fairly important for it. So first, talk about sort of a more traditional model that I was used to, which was you develop something, you release it, and you sort of pray for customers. If you're lucky, you have customers. If you weren't lucky, then if you still had money, you got to move on to maybe dealing another product. But that's pretty much it. It was shipped on disk. It was burned onto something. But that's not really the case anymore. Now, things are. We have networks you can deliver in real time. Now you can iterate on something and basically re-release it and learn from it. So if you look at a website, if you've ever looked at a Wayback Machine or something and tracked websites, they're dramatically different. And in some cases, week to week, they change dramatically. And for IMVU in particular, we were around for about a year with about 30 of the same customers not using the site before we started to actually get any traction. Each week we were releasing features until we found something that would keep them there. And your goal is to make it through this cycle fast. So for people that are more familiar with the lean startup methodology, you've probably seen this. And it's just another way of looking at the same process. Your goal is to make it through this cycle pretty quickly, because the main thing you want to do is basically find a successful product, a product that your customers will pay for or that you can monetize, that gives you the right to exist as a business and hopefully scale and reach greatness. And the continuous deployment that we go through is really about reducing the build aspect of this cycle and trying to minimize that so you can focus on the rest of it. And arguably, the building or the release part of software is about the least fun part. So if you can minimize it, I think it's more like ripping off a Band-Aid. Make it quick, get through it, and then kind of move on to better things. So reason number 1 why I think why continuous deployment is valuable is. Is this better? This better? Yeah. More than that better? Okay, I'm having a drink of water now, so I know.
Also, guys, feel free to tweet and share the hashtag LeanStartup or LeanLA and at @BDurrett.
At @BDurrett, B-D-U-R-R-E-T-T.
Take pictures, tweet, and we'll do it.
Can you repeat that? I couldn't hear you. Check in the Foursquare.
B-D-U-R-R-E-T-T. Which part did you need repeated? All of it. Hashtag LeanLA. I forgot what the other one was. Or BDurrett, B-D-U-R-R-E-T-T. So anyway, the first thing is the release overhead is reducing your opportunity to iterate. And I have package software here as an example because, again, I think games are one of the most difficult. And if you play games, you realize now when you actually buy a game, the first thing you do is you put it in your console and then you download a terabyte of updates before you can play it because this model's not really working. But anyway, when you have a really, really difficult release overhead, it's good news if you happen to have a product like this, if people know about SimCity. Again, if you're sort of into games as I am, if anyone knows about this game, this is the game that supposedly there were more units built than there were consoles that could play it, and there was a supposed landfill somewhere with every single one of them, except for the one that was used for this photo. So the second reason continuous deployment is so valuable is it's extremely easy to find a regression when you have a small batch of commits. I want to talk about a company that I used to work at where the release process was about a 6-week cycle. And a couple of weeks of development, a couple of weeks of sitting in QA and user test and scaling test and everything else. And then a couple of the last weeks and then we would roll out the software to the cluster. And the rollout involved basically a team of engineers sitting in a room, deploying the software to the cluster, and then scrambling to figure out what just broke. And it never got caught in QA. It wasn't that QA wasn't doing a good job, it's just that customers do things that you're not going to test for. And it's really difficult to test and scale for things that your customers actually do. So in contrast, I'll give you an example here. We would push out software and something like this would happen to a database load. And everyone's scrambling, and we're looking through tens of thousands of lines of code trying to figure out who the problem is. At IMVU, this represents about 30 lines of code. And the other thing that this represents, if you can tell here that this was something that happened at about, a little after 10 o'clock. There's a commit that happened right after 10 o'clock. Basically, finding the problem here is extremely simple. And since you have continuous deployment, it's very easy to roll that commit back. So instead of the hours and scrambling, it's an instant process to find and fix. The other thing continuous deployment gives you is extremely fast response times. And so again, using the previous example of the company, the response was slow because the push process and the build process, but even when we did find the one line in 10,000 that caused that, it took maybe another hour or two to get that fix out of the cluster. That's not the case. So from an engineering standpoint, this is valuable because you can very quickly address this and move on to better things in life. But let's talk about it from a product standpoint or a marketing standpoint. We've had things in our company where we get called and say, we have this phenomenal offer. We're going to give you this incredible rate on ads, but we have to have this out in the next 2 days because a partner that was supposed to deliver it over the last 3 weeks didn't get a release out. So we're able to take advantage of something like that. It's no problem. There's nothing in the release cycle. Releases are every 15 minutes. We can get this in there.
So is that real world? That really happened?
That has happened where we have had selling advertising come to us and say, this is an opportunity, but we need to be able to get it out in the next 2 days. And in some companies, if you say we have a 1 week release cycle, that's a problem. We're not, you hit us at the wrong part of the cycle. It's just not an issue for us. If we can actually get the work done in 2 days, it goes out. The other thing is, possibly, you guys are probably all better coders than me, but sometimes you get an exploit or something on your site or vulnerability that you need to respond to. Again, you can respond instantly. You don't have to have a vulnerability and say the release cycle is 2 weeks. We're going to be vulnerable until then. And a way to think about this is, if anyone's familiar with continuous integration, instead of your continuous integration sort of minimizes the pain from integrating. Continuous deployment minimizes the pain from deployment, for the pain from deployment. Again, from the lean startup, more turns it back. So if you're trying to find the right product fit for your company, you only get to basically measure each time you get a release out. So if you're a relatively fast company that's maybe releasing software once a week, so you need 5 iterations of a feature to sort of validate whether it's the right feature or not, you've got a little over a month before you can actually get that feedback. We're deploying, again, our release takes about 15 minutes. That means that by halfway through the day, we can have real customer feedback, real customer metrics, and at the end of the day, sort of have the data that another company could have had in a month. So that's incredibly valuable. It gives you more shots. And finally, there's people much smarter than me. Is anyone familiar with this book, The Principles of Product Development Flow? Okay, so it's actually it's a pretty good read, but there's a chapter. The 5th chapter is on reducing batch size, and there's also another good case study on how Facebook works on this. But basically, it goes through a ton of why is small batch, small queue is so valuable to companies, how this translates into opportunity and the cost associated with large batches. That's all about continuous deployment. And if you actually read this chapter, you'll find out that basically small batches and small queues are pretty much everything but whitening your teeth and doing your dishes. So this is how it works. Any questions?
Another question, which is this going to be available, this talk, on like slideshow or something?
Yeah, I'll make everything available. So you don't need to worry about taking notes on the actual slides unless you just are obsessive compulsive and like documenting
We'll
things.
tweet it at LA.
Yeah. So.
I got a question that I've never asked. I mean, how much is your volume of customer base dependent on how much feedback you can get in 15 minutes?
Yeah, so that's a good question. So the question was, how much of our volume of customer base is required to basically get feedback within 15 minutes? Yeah, it depends on the area of code. So there's some things that are retention based that 15, unless you have an amazing churn in your company of 12 minutes, 15 minute isn't really going to help. But so things like things that are fairly critical, like the funnel, so acquisition type things, where we have enough traffic that you actually can, within a few hours, actually understand how whether someone's converting to registration or something. Other features, that's not the case. So it's maybe an extreme case to say in 1 day you can do this. For certain features, it wouldn't apply. But as soon as you need to make an iteration on that feature, you can. You're not blocked by, again, we have an extra. Say if you're doing the once a week, you have an average of 3.5 days, before you can actually get that iteration out again.
Right. Well, I imagine validating problems is that hard, but validating success is harder.
No, success again. So it depends on which step of the process it is. Earlier is easier. Again, the farther it is along, it's difficult. You just need the more time to get that. So I'm actually going to walk you through this kind of step by step. So the first thing is writing some code, which I kind of skipped. You can pretend that you have an engineer working on a keyboard a lot. And one of the things about this though is all of our work is done on the trunk. We don't work on branches. So it's very, very, very rare that we do anything on a branch. And there's a few reasons for this, and I'll explain how this actually works in later. But one of the key things about this is you're avoiding merge conflicts. If everything's going out live so much, people are used to committing and pushing out. If something sits on a branch for very long at all, you're going to have to deal with a big problem when it comes to integration. And as a recent example, we had a new engineer start, and we're doing our stand-ups, and each day was reporting like what was getting through and everything. And we didn't realize that he was not committing though. He was doing the work but not committing. So after 2 weeks, we got to the point where we had to throw away 2 weeks worth of work because once we tried to do the commit, there were so many merge conflicts because so many areas of the code had changed that it was just easier to say, the code's moved on, we can't do this.
I mean, excuse this slightly stupid question, but I can imagine certain kinds of software for which this is more appropriate than others. Like if you were developing, very tightly integrated system software, with lots of event handling or whatever, wouldn't it be harder than like a website or something?
So the question is, if you were developing something like tightly integrated system software, wouldn't this be harder? My guess is yes, but I don't know if that necessarily means not possible. I mean, so I haven't done that. I actually don't know anyone that's doing that. I mean, I think one of the more interesting stories about sort of like types of sites that you can do this on or types of products. There's a company called Wealthfront, which was formerly known as Kaching, and they do a lot of continuous deployment. And what's interesting about them is they're basically doing trading. So they're securities trading, which means that they're regulated as both a securities trader and a banking organization, which means that things that go wrong can go very, very wrong in a financial sense. So while it's maybe different than sort of system software, it sort of strikes me. It's one of those where I wouldn't be surprised by the same type of question of.
That's slightly different problem. I mean, does like Chrome development, something like Chrome, it's sort of software in mind, and they have various channels.
I believe the way Chrome works is they actually do have a formal release process for doing it, and they do their updates in the background as opposed to continuous deployment. So anyway, so we're talking about the avoiding merge conflicts. The other thing is by always working on the trunk and not on branches, it means that all of the code gets validated in production immediately, so you can actually test this. And again, I'll go into a little more details about that later, so hold questions on that aspect. So I've now written my code. The first thing I do before I check in is I run through some tests on my sandbox. So this is our basically sandbox text suite, which runs this through a web browser. You'll notice that we've got various tags here, which are areas of our product, and I can select. So in this case, I'm selecting pets. I want to run all the tests associated with pets, and then I have my various options. Some of these things are like pause after failure, just to make it a little bit faster. If something goes red, you just want to fix it. Run test in random order. We'll get into a little bit more on the testing, but run test in random order is very helpful for finding intermittence. One of the causes for intermittence will be sort of state dependency, and this is a helpful tool for doing this. One aspect about a lot of the things that we have is we want to make it very quick and simple at every step in this process because we don't want it to be burdensome. We want it to be, it's simple, it's a click, the information I need or the next step is very, very easy to get to. So in this case, I've started my test. Down at the bottom here, what I would see is the actual test running. So these are test files, and they're running through several tests in them. And the output's very ideally green in each of these. If it goes red, that means I've broken something. And there's little helpers here. So there's the little indicator here is showing that there's warning messages. It didn't make the test go, but you can actually click on that and it pops up. The other thing, as I've moused over up here, is showing within a test or within that tag all of the tests that will actually run. And to keep things very simple, real-time access to the log messages as they're coming through. one thing I want you to note is some of the time for tests, because I'm going to get into some of this, which is actually ties into our history. Some of the setup tests are very expensive, 27 seconds. But even these tests that are 1 and 2 seconds, that seems like a relatively fast test. And I'm going to get into. Thank you for that. You know the punchline. I'll explain why these tests end up being very, very expensive.
Quick question, these tests are running before checking into the truck or after checking into the truck?
This is before your check-in. So basically I've modified my code and I'm just running through my test on my sandbox to say, did I break anything before I even push it to the next step?
Do you guys write your tests before your code, or do you?
Yeah, so the questions are, I guess, basically test-driven. It depends. We push for that, but we've found that we generally let people work how they want to work, like what's most productive, and we kind of came to that realization that a couple of our really super great engineers preferred to not be test first, and so rather than force the change and say work in a way that you're not comfortable with, we're not experiencing problems from that individual's code, so it wasn't really that big of a deal. There's a little bit of a possibility of having missed coverage as a result of that, but that's what we are on the side.
Do you still have those same engineers write the tests on the back end up?
You are still responsible for actually adding the test to your code.
Okay.
So it doesn't get thrown over the fence to someone else.
Oh, great, it's just not test first.
Right. So we push for it, but unless we're experiencing problems with someone, we don't mandate that it's test first. Some people find it a religion, but if someone's a great engineer and they're not test first, I don't really want to change it. So.
Did you develop this internally? Sorry.
So is all this internal? Initially, no, but a lot of it is actually highly custom at this point with custom test runners and such. And so,
Sorry, is this basically a website?
it's the website, but as you can see, it's running on your machine.
No, I
so
understand, but basically the environment, your product is basically
the
back-end driving.
Yeah, there's
no client dimension to this other than the browser.
In this presentation, I'm sticking to the website because typically when I present, I find that most people are actually web-based. But like I said, we do have a Mac and a Windows client, and they actually we actually do the same process for them. If you want to come back to this at the end, I'll kind of explain some of the differences. But we do this with client software as well. Okay, so the next step is lots and lots of test run. And what this means is, how many people here are, we'll say not familiar with continuous integration? Okay. So the idea here is this is a server, you check in your code, and the first thing it does is it takes all the code and basically does a build. And as part of this build, it runs through a set of automated tests to basically validate that everything that you think should be working is still working. We happen to use BuildBot. This is, I'm not sure what the adoption is at this point. It's happened to be what we chose. I know people use Hudson as a popular, Jenkins, and I haven't actually used Bamboo, but I threw it on here just in case people were looking for basically various options. No matter what environment you're in, there's probably a free continuous integration server available. I'd be very surprised. So this is actually what BuildBot looks like. There's several views. There's a waterfall view. This is a console view, and this is the servers running. And each of these boxes here actually represents a server. So I don't know, we're at 40, 50 or something like that. And the reason for this is if I were to try to take my computer and run through all of the tests that we have at this point, my computer dies at somewhere around hour 8. No one actually does this. It's just not feasible for an individual to run through this on a single machine. So we split all the tests up between multiple servers. And what this does is it takes a build time that was normally 8 hours. And in our case, the builds are right now, I think, running at about 8 minutes, which is materially different, as far as productivity. And each of these servers is running many, many tests. So we have over 40,000 automated tests that are being run through this test suite. I know, I found this kind of fluctuates a lot between industries, but going back to games, I found a big anti-testing in games. The value of test, particularly as you have a growing company and a growing code base and more and more people working in it, is it gives you a contract that you can make changes and that you haven't broken something, possibly even in a system that you don't know about or don't understand yet. It's very helpful for new people to feel comfortable that I've made, that the change I'm doing is not going to take out the entire cluster. I'll get into this a little bit more later, but there's two types of tests. There's the functional test, and the way to think about this is it's sort of an end-to-end, like I'm testing a feature. Maybe I'm registering a user via the website, so it's actually entering a name in a dialog and clicking on a button and making sure that a user got created. And there's unit test, which tests sort of a very specific block of code and saying, is this piece of code functioning how it's supposed to? I was looking at a presentation recently that was saying, they're really big on functional tests. We used to be very big on functional tests until we realized that we were dying under the weight of them. They're very easy to write. You need to have them to test the end-to-end experience, but it's hard to have lots of them because they are, typically they are creating real database calls and everything, and it ends up being, several seconds to run, particularly on a sandbox machine. We'll talk a little bit more about that in scaling. So, so we've run through, this is build out, we've run through all of our tests. And let's see, we're going to go through the unfortunate thing is, did all tests pass? And we'll say no. So what happens now? I just push something out, and the continuous integration server says my code's no good. And one of the questions would be, well, why is this possible? I thought you ran this through test in your sandbox. There's a few reasons that code can actually get here after you've run it in the sandbox. One is intermittent tests, and these are tests that are just simply flaky. They don't, for some reason, they give different results with different runs. That happens sometimes. More commonly for us, it's the missed tag. So I made a change to code. I thought I tested everything that it touched, and I didn't because I can't test all 40,000 tests in my sandbox. This is the first time we went through the complete set. So what happens is I get basically an email goes out. The system is shut down, so commits are locked. If I try to check in code, I'll get a message back saying BuildBot is locked. It's red right now because of a commit. And immediately what happens is the engineer is supposed to revert the code. So we do have a couple of exceptions to this, but the idea is everyone in the company, we have 50 engineers that need to use the system. If someone's holding it red while they debug it, it's not okay. So instead we save all the information and make sure that it's available. And so you can see up here, there's basically what failed. Here's the test output file, which is saved even when they revert. And if you wanted to, here's the link to running the test locally in case you didn't realize this was the test you need to run. Plus all the information, if you scroll down, that's sort of relevant to this test. So again, you have a failure, but it's very quick access to the information, almost instantly giving you what you need to fix to basically make this test go red, or to go green. Let's go on to the happier path on this one, which is your code didn't break any tests. And now we're going to be deploying to our cluster. Excuse me. So the actual deploy, the code that gets rolled out to the cluster isn't really exciting. It's a bunch of Perl and rsync code. And it's Perl because, unfortunately, I put it in there, and I've been blamed for it since. It's pretty simple. We have a set of machines that we've chosen to be sort of the initial deploy machines, and it does an rsync out to these machines. The mechanics behind this, if you want to get into the details, is basically we have symlinks on the site. We keep multiple copies of our code, and so the process of rolling forward and backwards is just simply changing a symlink. That's not actually the hard part here. I think everyone probably understands how to copy out code to servers. Well, hopefully most people do. The hard part is the cluster immune system. And this is the thing that is now responsible for making sure that what code just went out in production doesn't take out our entire production cluster and take us offline and have us start losing money as a business. And what the cluster immune system does is it's watching metrics. And it's watching performance metrics of the systems. It's watching key business metrics. And it's looking for any changes that happened as a result of the push that just went out. And in most of the cases, I think if you've been established for a while, these are probably things that you should, as a company, be monitoring and alerting on already. And so tying these into the system is a great first start. And here's an example. We've used Nagios for years, and a lot of people use Nagios for basic system alerting, for CPU load and stuff like that. We use it also for key business things. And so If you look here, here's some system performance stuff. And there's a bunch of things on here that sort of may seem obvious, like disk space, is there enough space on the machine? There's other things that may seem a little bit odd, like is there a DNS drone running, or actually, let's see, is cron running, which is probably something most people don't check. Almost all of these were the result of some failure at some point that led to a business failure. And we just said, hey, at some point some machine wasn't updating something and we realized cron wasn't running on it. We just said, let's add a test. This machine, now machines will never come up without cron running, and we don't have to worry about debugging that ever again. But the other thing here is the business performance, and you see things like AOL import and Yahoo imports and chat service, is it running? And actually it's even monitoring our systems that make graphs and saying, is that upload? Is our graphs actually graphing what they're supposed to be graphing? All these things, revenue, registrations, absolutely key to the business. So we track these, and we just roll these into the cluster immune system.
When you say that you're monitoring changes in these metrics as a consequence of the push, is that for a specific period, or are these continuously monitored metrics? And if they are, how do you link them to a specific push, or do you?
So the question is, are we tracking these as related to a specific, or are we tracking these related to a specific push or for a specific time period? And good segue. So this is where a rollback happens. And when I say rollback here, I'm not talking about sort of an SVN rollback. I'm talking about the cluster immune system now changes the symlinks back to the previous release. It also now blocks commits and says something has gone wrong. Okay, go ahead.
Yeah, I had a question about how do you deal with that when, for example, the commit has a database change?
Good question.
How do you roll that back?
I've even got a slide for it. So.
How do you deal with the scenarios where commit may cause an issue that would cause it to block, but during the time that that test is running, determining that block, somebody else has another commit?
So the question is, how do we deal with during this deploy that it's gotten blocked, but someone else has made another commit?
Yes.
So their commits are actually, they're already committed, they're on hold, but it won't actually now push it out to the cluster because it's going to say at that step it's blocked. So the actual push out to the cluster will have basically a gate there saying nothing else goes through. So it's possible. I mean, the way the build systems work is you basically hop on to the next build. So a build could have 3 or 4 commits in it, and as soon as a build is ready, it starts the next build. So it's possible that you're 1 or 2 back in the queue for getting out. If it's
when that person fixes their problem, does it go to the end of the queue, or does it go back to where they were?
It depends on the type of problem that it caused and such. Again, we usually we err on revert and then get back in line. And I talk about this a little bit about the culture of things, but you end up, when you're a small team, you work very differently than when you're a large team. And you have to change, you kind of have to change this as you get a little bit bigger. So this is what it looks like. Now we're actually on our production cluster talking to our immune system. And we have to diagnose the rollbacks. And so again, we make this relatively easy. So we have a couple of things on here listed which are showing some of the things that are being monitored. In this case, basically the push has increased too much, or aggregate load average increased too much on this. And this is kind of an interesting one. We end up having false positives occasionally. And this is one of the unfortunate things of the system. And the false positives are largely because we actually get real variability in our business. And some of the extreme ones will be, we've done sales before where our revenue changes dramatically during a couple of hour period. And what systems are seeing a huge, even though they see a huge surge in revenue, they think maybe something's wrong right now. And so this has been one of the tougher things. It's also been one of the reasons why whenever we look at these systems, almost everyone says, oh, we got to get predictive monitoring. Predictive monitoring would be great for these things. And almost every time we rolled it out, we end up with a lot more false positives just because of real variations. And so many of the things that we actually look at, we pick absolute values that seem to be well within normal operating range, and some of them are actually based on just a delta.
Sorry, so are some of these variations things that there were business reasons for that some departments knew about and simply didn't communicate to you?
So the question is, are some of these variations that a department knew about but didn't communicate to us? No, we're pretty good about communicating. I think that some of them are just we don't go in and modify the system on an hour-by-hour basis by something, and so so in the case where I say I was looking at this and I say, oh, the loads are higher, but actually what's happened is we knew that there's a very special poll that the BI team is doing something, and we knew that there was going to be higher loads. They would just say, we understand what's causing this and push it through and let it go out to the rest of the machines. Or things, we don't go and adjust all the revenue numbers as a result of a limited sale. But again, very easy to get to on all of these things, so make it fast, quick, and easy for people to get to the information to fix the problem. As I walk through the other kind of stages here, so this is phase 2, is where we go, the point is to deploy all the servers. This is exactly like phase 1, the only difference is instead of it going out to 30 or 40 servers, it goes out to the entire cluster. These wait periods here are on the order of a couple of minutes. In most of our metrics, this is probably more difficult for a site that doesn't have a lot of traffic, but within a couple of minutes, we have a pretty good idea of whether we've done something really silly. One of the things it's not really good at is catching very small changes. So if we shot ourselves in the foot just a little bit, that sometimes gets through. So anyway, that all goes through. If it's a rollback, it blocks. It's the exact same process. But otherwise, if it's, assuming that there's no rollbacks, 2 minutes later, it's all clear, it's green, and our customers are experiencing the new code that just got checked in. Any questions before I go on to getting started?
Yes. Now I don't know if this is a dumb question, but how do you manage the deployments of your deployment system?
So the question is, how do we manage the deployments of our deployment system? We have a deployment system now. That actually might be a bit of a stumper. So early on, it was just a manual. So it was actually within the last year that the deployment system got all put under proper test coverage and everything else itself. So it very much was something that was hacked together and sort of built on. And I think when we actually did all the work too, I think we'd even, some of it wasn't even in a repository, I think we found, where it was sort of, it had been hacked out and stuck out on a machine. So that's, now we have the ability for, it goes through a normal deployment. I don't actually know the details of how that happens, but we don't actually change the deployment system that often.
And then does that tie into a similar answer for when you need to make infrastructure changes? I mean, like adding things to the cluster, or is it fairly node independent, if that makes sense?
So the question is, does it tie into making changes to the cluster, like hardware changes, or is it node independent? Hardware changes happen completely independent of the system. The only way the way it works is Ops has a database of machines, and when they just deploy a new machine, Ops basically uses Nagios to say everything's gone green, which is effectively their test suite that this machine's ready to start being part of the cluster. Okay. And then there's a flag in their database that says, I'm ready to be part of the cluster, and then the deployment sees it as just another node. There's nothing special about it. There is one of the tests that actually allows it to actually be active is, does it have, I think 5 copies of the source code on it? Because one of the problems you could have is we just deploy 20 new web servers. Someone deploys to it and then tries to roll back only to find out that there's nothing to roll back on. So there's actually a Nagios tech check that's looking for how many versions before it says I can participate as a web server to the public.
But in the beginning, it's very almost where you started with anyway. I mean, before you even had a continuous deployment system. I find just system administrator and coder, I break a lot more things on the system than the code, hands down. Or even trying to build test suites or checks or install Nagios. Oh, look, you took something down. And I'm just wondering if there's any brilliant way to manage that, or if it's just kind of get it out as quick as possible so that it can protect everything else.
So I think I'm lost on the question. Why don't you grab me afterwards and I'll check. There's still a lot more of the presentation, by the way, so.
Sure. So I see you've got a lot of unit and functional tests and system-centric tests and then business tests. Do you have anything that tests like appearance type thing? So if developers check something in and it just doesn't quite look right, so that gets pushed out to customers?
So basically the question is, do we have any aesthetic tests?
I mean, I know it maybe it's impossible, but...
We don't. I mean, I guess...
Is that a problem ever?
Yeah, we certainly push out some ugly stuff sometimes. I mean, but it's not, I mean, I think I think again, the feedback loop fairly quickly. I mean, I'll talk about one of the other aspects about whenever someone makes a change is they send an email to a change list, which effectively goes to every single person in the company, and they usually document the before and after. And since people are checking in stuff so often, that's a good way to keep a pulse on what actually just went out. And you'll see things. We actually just had something go out 2 nights ago, and someone checked it in, and they sent their change with a little photo of like, here's what it looks like on the website. And within minutes, 2 employees responded, you've got a typo. And 15 minutes later, typo's fixed. It's sort of, people look at what's changed. So if you went in and put something really aesthetically unpleasing in there, someone would probably say something. One of the designers would probably come up at some point and say, what were you thinking? When you did that. You first.
Is it a challenge to break up big features into few hundred line code?
Is it a challenge to break up big features into a few hundred line codes? No, and I'll get into why. I'll get a little bit.
Have you done any code segmentation at all where you actually have more than one of these systems running in parallel, or is the queue just one monolithic code base that gets queued up?
It's basically one monolithic code base. So it's so the way IMVU started was largely by grabbing a tremendous number of open source projects and rolling them up into a large ball of code. It means that you have a monolithic code base kind of from a base. And we've been breaking that out, but it all gets tested as one giant code base.
Have you thought about deploying multiple continuous deployment systems and
Well,
making up your team a little bit more?
We have some other things we're doing in the company to actually address that. So I guess probably the answer is yes, but nothing I'm going to be covering in this.
Kind of a related question to this one, I suppose, which is, and to your question, is there a danger of this if you end up with kind of local optimization? If you get local maximum, but you're seeing other opportunities because of the small step size compared to counties.
Yeah, so the question is there a possibility of getting into a local maximum? So I think that's actually more of a product question than, from an engineering standpoint, so this method of working can feed into that very much so, especially when you tie it into a tight feedback loop and A/B testing and such. I think that actually there is a very real pitfall of that happening. But I don't think that's this system is more of an enabler rather than sort of the cause. It just makes it much more effective to do that. But I don't think it's inherent that it has to happen this way. I'll take one more question.
I just have a question about code coverage. I don't know if you're going to cover that.
No, probably not. So
yeah. Okay. So how do you ensure code coverage when developers check in? Is that part of your continuous integration stuff?
Yeah. So the question is, how do we ensure code coverage? We actually don't have anything that's ensuring that everything has code coverage at this point. One of the things, as I mentioned, the way we grew. I'll just go ahead and talk about getting started because this kind of ties into it. I'll just go ahead and talk about getting started because this kind of ties into it. So, frequently when I talk to people after talking about this at conferences, they'll talk about, oh, well, it's so good that you built all this stuff right from the beginning, and it must be nice to have this system and having the coverage and stuff. But getting started is actually just more of a matter of like doing something to start things moving here. And we've actually always been having continuous deployment on the cluster. We still had no customers. I was actually started probably about 9 months after the company had launched. So there's no customers, and I came in an operational role as opposed to just engineering. And the deployment system at that point was you wrote code, and then you SSH'd it out to the cluster. And that was pretty much it. And so there was no monitoring, no alerting. And as an ops guy, one of the first things that I did is start saying, well, let me put in some metrics for the website, see what's going on, and start alerting on this. And I started finding I was getting paged a lot. I'd log into the website and I'd see a PHP syntax error on the front page. I'd be like, oh, okay. And the person had checked in and gone off on a bike ride. And so, but the point was, and the good news is there was only, again, 30 customers at that time. So the odds of any of them seeing it in an hour is, But the important thing was it really set the culture of it's about getting this stuff out there. And so, one of the first things I did was write a Nagios check saying, are we rendering HTML? Like, is there really something coming out to the customers? And that was one of the starts. But we still worked this way for a long time. We ended up with an interim server that it went to, and then would like SSH out it to. And we still didn't have a continuous integration server. What we had was just a test suite that you ran in the sandbox. And the idea was, just if you're writing new code, it should have some coverage. And at that point, almost everything was a functional test because it was the easiest thing to do, which was to get a web page and see if the text was there. But the point is, it was all about just starting. There wasn't we have to have a bunch of stuff. It was about get in the habit of doing this. I'll talk a little bit about how to do this more with a more established product, because I think when you talk about like getting started with continuous deployment, if you're a new company or you're starting up, the good news is you probably don't have any customers, and that's probably not the good news overall, is because it's a new company, but it's good news in this. Your strategy is a little bit different. What I think would work best in this case is start with your sandbox, start getting some test coverage, because this is one of the areas that going back has always been very difficult for us. There's a lot of work to put old code under test coverage, and there's no customer-facing value when you do that. You can argue that it pays off in customer-facing value, but when you're running a company, it's very difficult to make that investment choice to say, we're going to spend a lot of effort, customers won't know. And just push. Like I said, we didn't have anything fancy, but if you get in the habit of saying, I want my software to be out there, and I find a lot of companies, small companies, just do this. It's someone hacking on their laptop that basically just copies it out to their web server in the first place. The problem is people tend to let go of that when they start working with a few other people. You have 4 or 5 people, you're stepping on each other's feet, all of a sudden you feel like we need a formal process for it. If you adopt that formal process, I would hold on to the fact that you actually still want that. I want to get that out in front of customers very quickly. And like I said, this is the ideal time to be failing as a new company. This is when you can afford it, when you're not going to have people running around talking about how much money you just lost. If you're an established product, I think it's a little bit different. And this is more of my best guess. So my lawyer has made me state that if this doesn't work for you, it's not my fault. But I would actually work backwards. I mean, what I'm saying backwards from sandbox, which is start with production. Because my guess is if you're an established product, you're probably deploying your software somehow. And there's probably some manual QA, some step of that actually could be automated. And worst case, I would suggest an approach where you try to automate that. So first automate this, like getting the code out to the server. Still at QA or whatever your formal process is working, but get down to it where it's a one-button push and it goes out to the servers. And from that, you can kind of work backwards and start saying, what was it that QA was checking? And can we start automating part of that process? And once you start automating that, you can still have them run through it, but saying, hey, we're going to let the automated test find it and see if it's missing anything. You can start building up the confidence that, hey, our automated results are producing the same results as a team of people to run through things, and eventually start turning these things on. One of the key things, though, is commit to making forward progress on this. And the way that we did this at IMVU was new code had to have test coverage, and when something old broke, you had to have test coverage for that as well. So as I said, we still have a tremendous amount of stuff that's not under test coverage, but it's really, really rare that someone pushes something out that actually takes out the cluster. It's almost, when it happens at this point, it's almost sort of like witnessing a miracle or something, and you need to call the Vatican because someone has done something that's somehow didn't get caught under anything. It still happens, but it's a big surprise for us. And the other thing is, I talk about the pain of slow test, but I think more important than worrying about the pain of the slow test is to basically get the test in there. So if basically writing quick to write, simple functional test that runs slowly is best for you early on, I would say take that approach over no testing. Finally, set expectations in a company. This is a really amazing system. We spend a lot of our resources in the company actually have been spent on keeping the system running. And when I usually will break this down, and at times we've actually spent up to 20 to 30% of engineering maintaining the system. And when I talk to product owners and various other people in the business owners, say, here's where our time is going. Invariably, the feedback is that's well worth it. Like that cost is worth it to the company. So it's not just a, hey, engineers like this. Product owners like the ability to have this flexibility. So it offers a great opportunity for people, but I would expect some pain. You are going to have cluster outages, and they're probably the same types of outages you would have had with your traditional, manual process. But people, when they're switching to a new system, sometimes say, "Oh, see, it doesn't work." Set the expectations. It's going to, there will be hurdles. We'll get through it. And if you have a culture, I really benefit from the culture of the company where failures are looked at as opportunities. It's diagnosing how do we learn from this, and how can we get excited about never letting this failure happen again. That's a great culture that sort of enables something like this to happen. If you have a culture that's more of a look for fault or blame, you're going to have a little more challenges with this. So I want to talk about scaling with continuous deployment. And I chose this slide for two reasons. One, because the guy gave me permission to use this picture. But the other one was, this was where we first started having huge problems with our system, and it was scaling. And the problem was, basically, BuildBot would go red, and everyone is blocked behind that person. And this was several years ago. The build times would be in the 20 to 30 minutes. And there was a problem with intermittent test. And what would happen is someone would make BuildBot red, and they would try to, rather than revert their code, fix it and try to get a release out again so that make sure that it would kind of go through, because that was really most efficient for the individual engineer. For the 19 other people, not so efficient. They're waiting. So while this person has now spent an hour and a half getting their commit to go through, you've got 5, 6 more commits that have been put in. So now you have a lot more pieces of code that are going in. With every one of those commits, there's an opportunity to break the commit system again. And so the next one that goes through is much more likely, and now there's more people involved, and now they have to dig through and see which commit broke it. So I thought about this as sort of the single lane thing. It ran well, but at some point we got too many cars on the road, and we hit traffic, and things melted down. And the solutions to this, we thought was, here's an easy one: build isolation. And this idea is that basically when I check in, if something goes wrong with my build, we move it to the side, so that basically your broken car has been pushed off to the side of the road and all the other cars keep going by. If their commits it may be odd that you think about it where, well wait, I'm actually a further revision forward, and we're rolling that out and we're missing a revision. But if all the tests go green, that code should be able to run on production. It's, we're testing for the things that are critical. So we thought this is going to be the best way to solve this problem and make sure that the build system is always available. Wasn't. So the good news is, I guess we didn't actually get around to building this, even though this was the big plan. And what we found is that we didn't need to build it. And that what really made the most difference was fast test runs. And the solution to a lot of this was buying hardware. So we run now on just big beefy boxes that have, I think, 10 virtual machines in them. A lot of these processes are single-threaded, so each core, basically using multi-core, it's easier to basically shoot into single cores as opposed to multi-core machines. Getting into too many details. But we're the business at a point where rather than go through and try to worry about making all of our tests a lot faster, it was just easier to say throw hardware at it. Engineering time is a lot more valuable. A couple of the other things that made huge differences in the test time were actually sorting. We added a test metric system, and what this does is it watches all of our tests and it keeps data on the success rate, how much time it took, and that gave us the ability to start sorting our tests by speed. Because what we found out is a lot of our builds were blocked, where all the builders were completely done, except for one, which had a 2-minute test running for some reason, randomly. And so everything could have completed a few minutes earlier had the test been sorted a little bit more effectively. And then in a couple of cases, we added dependency injection, which is basically, it's a way of saying, don't make all of these real calls to the database, which are very heavy and actually have to go through a real database, but we're going to give you the data that the database would have given back, and it runs substantially faster than a real sort of test.
How much parallelism is there in running test runs? I've got 50 developers. How many test runs can be run in parallel?
So if you have 50 developers, so there's only one being run at any time across. I think it's 40 or 50 effective servers there.
So you're assuming that there is potential functional dependencies, right? Because otherwise you could run some in parallel, right? do know that this.
Oh, it actually has more to do with the test runner than anything else about the. There actually is, so the question's about is there dependence between the tests? There actually is in some weird ways, between different tests because of ways that they. So because many of the tests have to have a special setup when they're actually doing real functional tests on a real set of data, they reuse a database, which means that if they're modifying that, they can actually affect the results of another test. So that's one of the key reasons.
So it's anti-single threaded testing.
Yeah. So
It's the hardware.
hence the hardware. But if it was multi-threaded, we'd be using the same hardware, probably just with less virtualization. So the other thing that we added, which was a huge win, which was the hypothesis builder. And in a way, this was actually the build isolation, which was effectively you tag your code and say, I want this to run on the hypothesis builder, and it just runs. It doesn't go into the main. It doesn't go into the main build bot. It actually runs on the main build bot, but it basically on similar systems, but it doesn't block anyone if it fails. And so this gives you the ability. Hey, I've made a bunch of changes. There's no way I could run all the tags in my sandbox, but I'm going to make sure that it actually passes before I commit it to the real build bot. All of these things together got our build times down to below 8 minutes, or right around.
Running parallels in that.
No, it's the same set of tests. It's actually so, but that's what VMware is for. They have to we've got to make a buck somehow. So anyway, what we found is when we had this, we realized that we didn't need build isolation anymore. Even though the other thing we realized is we'd always shot for having build times above 90% or having a build availability. And then recently we realized we've been dropping below that, and no one cared. And they didn't care because it wasn't causing an impact to them. So we realized that the fact that the builds were relatively quick, there was a fast rollback, and that they had a way of keeping it mostly green, that an 8-minute kernel wasn't that big of a deal if it went red. So we actually ended up moving our SLA down based on real feedback. And this is actually interesting. When builds were over 25 minutes, it's a huge cultural issue. These are people, and people we hire come from places where they ship software once a year. It goes over 25 minutes, and people are pissed off. I mean, it was ugly. So talk a little bit about flaky tests, and these are basically intermittent tests, or the tests that you can run them once and it goes green. You run them the next time it goes red, and I've talked to a couple companies about how they handle this, and have been surprised by the number of people that ignore or disable the test rather than deal with it. And out of both of those, I would say disabling the test might be the better option. Sources of flaky tests, the things that really hurt us the most are third-party integration. So we deal with 15-something payment providers and various other services. Our code has to integrate with them. It's critical for our business to be running, so we have tests. Unfortunately, these usually have to go over the interwebs, and the interwebs are not always reliable, so you're doing a build, packet loss or something, and test goes red. The solution for that was basically providing sort of a service provider that effectively gives back the same results as the third party would have given back. The other thing that has always, that's sort of bites us is time. Writing tests around time and functions that are supposed to be over time spans and like how much time has passed are really far more challenging than I think people realize. And so pretty much every leap year, every sort of daylight savings time and something like that, we end up with a bunch of tests that say this doesn't account that an hour from now is actually the same time as right now. And so those are kind of a common one. And the other one, which we don't have as much anymore, is state dependency, which is the results of one test depend on the state of another test. And the way we deal with that is overnight, when the test system's not really being used, we tell it to just keep running tests in random orders until it goes red. And so the next morning we can come in and say, hey, here's a bunch of tests that were red that must, by definition, are intermittent because they were green when the night started, and at some point during the night they went red.
Do you have a lot of code in JavaScript?
Do we have a lot of code in JavaScript? We're getting more and more code in JavaScript right now.
And what's your experience with large?
What's our experience been with JavaScript? I think a lot of that actually gets tested via the functionality of Selenium, although we're starting to do more JavaScript unit testing as well.
haven't had a state problem.
So, I mean, I don't know. Selenium's kind of always been a suspect character in our office, but we have had things. Well, we have had things where they go intermittent because like IE does something weird, and you just kind of say IE did something weird, and that's we don't write a letter to Microsoft or anything. We're not that hopeful that. But we do tend to understand that it was actually, it appeared to be like a browser crash. We've added logging and stuff to try to figure out, was it our code or was it something beyond our code?
You struggle with tests that are future time-based, where you have to turn on and off functionality at a particular time of day.
So the question is, we have a lot of tests that are future time-based about turning things on. We don't have a whole lot of stuff like that.
I see.
My guess is that type of stuff would have a lot of bad test written that would get corrected. I mean, again, it's pretty much like we've spent a lot of time dealing with time. It's surprisingly tricky, and when you have new people come into the company that haven't lived through the correcting all the time functions, you end up with sort of something that seems like an obvious that an hour from now seems like it would be an hour from now, but it's not. So one of the things that also was a huge help there because actually we kind of go into like the cost of intermittent tests, and so we're running about 40,000 tests at this point. And so even if you have, let's say you're saying, hey, look, we have 5 nines of reliability, you're having pretty frequent test failures at that point if you're running through that many tests. So these are things that you'd be commonly slowing you down. So it's pretty important to get these fixed. One of the things that we found is basically moving them from having to fix them as they happen to being able to fix them when it's more convenient or it can be scheduled is really helpful for helping be more predictable as a company and help, so we don't have to derail product and say we have an intermittent test. One of the most helpful things that we added was now on BuildBot, when a test goes red, the first thing it does is it runs the test somewhere else, and if it goes green, it marks that as an intermittent test. It doesn't block on BuildBot. It says that the test went green at least once, so we're going to let it go through. But it automatically opens an issue in our issue tracker saying you have an intermittent test, and then at the end of a sprint or when we're planning the next sprint, people can go through it and say, oh, here's our intermittents that we need to deal with.
So you will push intermittence into production?
Yeah, we'll push intermittence into production because it works better for us. It's just, we found that the predictability around our work schedules, being able to deal with them on a time frame was, probably better than taking the hit, and the actual impact of productions, it's very rare.
Have you found that as you build up a backlog of intermittence, have you found that the patterns, in other words, you solve one of them, it ripples out actually, you solve like 20 or something. Have you found they tend to revolve around origin?
It depends on how far we get down to the root cause. So if we do a full root cause analysis on stuff, which usually ends up being a lot more work that has to be done, but yeah, you'll see it. You'll see that. We did a lot of functions about how we deal with time as a result of just we keep having these problems. Let's actually put together some functionality that will help people when they're dealing with time. We also do. We put in a lot of commit hooks to prevent people from doing certain things that we know will more likely lead to an intermittent. Some of the trickier bits. So a couple of things that continuous deployment doesn't do very well, or at least for us. Things that fail slowly. And this is one of my favorite queries, which I used to see a lot of. If you have a customer table and you've added a new table that does, adds a row per customer or something, this looks great in your sandbox. And actually, for a couple of hours on production, it actually looks pretty good too. It's a pretty cost-effective query to be running. Once you start getting into a very large full table scan, you start realizing that your databases are melting down, and it's a little trickier because it's not obvious when your database started melting down. It was kind of a gradual thing, and usually it's been because some critical resource is triggered. So you see the edge condition somewhere, and it's not exactly where the commit happened. For this particular thing, we've done a couple of things. One is this actually process-wise. Changing schemas, or basically when you deploy a new schema, this is something that actually requires sign-off from a tech lead and multiple people sort of reviewing it. And the reason for this is because we're using MySQL, large tables, alters are very, very painful. And so this is one of the areas where we actually have a few people review it and say, do we actually have all the indexes that we want on this, and is this something that is likely to sort of scale with us for a while? The other thing that we added is a query killer. So in operations, we have something that runs and watches the databases, and when it sees a query that gets out of control that's likely to be something that's going to be ending the database, it just issues kill statements and starts knocking you dead, realizing that it's better to have that functionality in the code die than it is to have the database be overloaded and take out everybody. And then for how we actually deal with a schema alteration for these large tables, we basically deploy a new table and then we do a copy on read, and we have a background process go through and then migrate all the remaining data. So this is kind of a burdensome piece of code to write, which is why we actually have the upfront, like to try to get it right early on. So people want to really not be doing that, sort of the cleanup process on that. A couple of other things are some critical areas that are lock up pretty hard when you get them wrong. MySQL to some, so basically at the database layer has been one of these things, but more, the one that actually is the riskier, that we have a lot of commit locks on and requires another couple of eyes before you do anything, is where we deal with memcache. Some of the more spectacular failures have been someone adding a counter to memcache calls to see how many memcache calls were going on. But that memcache call called memcache. But these are some areas where they basically hit the cluster so hard that they can basically get machines to, like, the loads are over 100 and you can't even SSH into boxes and stuff like that. And so the problem is, it doesn't hit in your sandbox because you don't have 100,000 customers in there. It doesn't hit when you first, or it doesn't hit even to the test because it's not able to test at that scale. And then the second it gets out into the production cluster, it's instant death. So the way we've solved that is really by just putting some locks around a couple of the areas that we know are just pretty challenging. I've covered this a little, lack of test coverage of older code. If you start with test coverage, that's great. We have a bunch of areas that people are terrified to work in because it is one of the areas where you might push it out and something might legitimately break. The immune system will probably roll back that stuff because it will catch it as a result of a higher business function. That's one of the nice things. So you may break something, and a separate metric actually is what saved you. Yeah, the rollback is completely automatic. And then outsourcing, which is one that I started looking at last year. We were trying to work at a team with outsourcing, and I realized that they were on another continent. They needed, they were very much used to, like, we build something, we integrate and roll it out, and we're like, if you build for more than a few days, we're not going to be able to integrate ever again. And so we didn't really solve that. So.
How do you deal with the time difference between the code being deployed and the schema being applied? The schema changes being applied.
So how do you deal with the difference between the code being changed and the schema being applied? So the schema goes out as a separate. So the way our schemas work is they go out separately, and we have one person. Well, there's a couple of people that can do the role, but there's one person that applies the schemas. And the reason for that is also it's the final gating factor on, did we review these schemas? So the way it works is schemas get deployed, and then the person who's wanting to deploy the code says, hey, it's basically dependent on my check-in being sort of activated when that goes out. So,
but for that time, the schema is now different than the code expects.
But that's why the new. It's typically we're not altering schemas, so we almost always add something. We don't do an alter. So the idea is the new table gets out there, and the new table is just waiting until there's some code that'll access it. So schema goes out first, it's idle, no one touches it, and then the code goes out and then starts accessing it.
What about changes to the schema that require data migration?
So that's exactly what I said about the. So what about changes to the schema that require data migration? So you're talking about maybe adding a column, or you're talking about.
I can't think of a simple example, but.
So one thing that might be, let me give an example of maybe you have a customers table that has all the customer information, and then you want to add something about that customer, but you realize that it's a gigantic table. Then doing that add or that alter on the table is going to take out your database for 10 to 20 minutes. Is that?
Or say you need to.
I have an example of the same question
Okay.
that I go with all the time, and it's always on our users table. I'll put in a field that's just supposed to be a flag, and I'll push the schema out first with the not null flag unchecked. But when I finally get the code in production, I want that not null flag checked.
Right.
So I have to do it in a 3-step process because I originally would push out the not null, the code wouldn't be ready to fill it with the data value, and then somebody couldn't join. And so I was taking off the join funnel over and over and over again, and started doing it as a 3-step process, but then sometimes have, you know, null fields that I really didn't want after the fact.
Yeah, so we typically get the schema out exactly as it's going to be operating in production on the first time, and we just don't do alters. So if it's a new table, so well, there are some exceptions. If it's an unpopulated table, so if we say we push it out and only QA has been accessing it, we know that an alter is going to be safe. So there have been tables where we look at it and we say this table has 28,000, 50,000 rows in it, you know, spread across, we're horizontally partitioned, so it's over a ton of cluster, or a ton of databases, but it's a very small, it's not going to be a material impact to it. We'll go ahead and allow that. But if it were something like our customers table, which we have there's one table that does have that table has not been altered in forever. If we actually had to alter that table, it would be sort of a copy on read, and then go through and migrate all the customers that haven't accessed their data in a while. So that's typically how we work. Sorry. Okay, go ahead.
Can you imagine your process working if you were like 10 or 100 times bigger?
Can I imagine my process working if I were 10 or 100 times bigger?
500 developers or 5,000?
Not in a monolithic code base that we have right now.
Yeah, that's...
So the question, yeah, I mean, the system's not the problem. Like this continuous deployment's not this problem. I think that the code base that we're referring to wouldn't scale like that.
So you have to have parallelism in.
Yeah, like as I mentioned earlier, we've got other things that we're making changes to the company and the way we work, and to sort of take that into consideration. That
because you've got like 100,000 active users.
Oh, we got many more than that.
I'm talking about.
That's just actually when I use the.
At any instant.
Well, that's 100 to 150 people actively logged in and chatting to each other.
Exactly, yeah.
On the site, the site's a multiple of that. The people accessing the web functions are much higher than that.
Okay.
So I'll keep moving on. Where are we on time? Just one.
We don't have an hour. Yeah. How much further? Yeah, how much longer?
As long as the bar's still open.
Yeah, okay, yeah, so I guess 2 a.m. is the deadline here, but no, I just want to be sensitive, I don't know.
Well, what we usually do if it's going on longer and then the audience is engaged and enjoying the content, what we'll say is just, make yourselves, come up, get some pizza, grab something to drink, use the restroom, and, feel free to do that, and we'll continue, and then if you need to leave for some reason, that's okay. Just,
okay.
You can.
Yeah, when I do it, I'm not used to doing it with all the questions in the middle, so I have no idea how long it'll be. So we'll keep going.
Keep going. We need to grab pizza guys with a beer.
Sure. Let me move on, because we certainly will always have more time for more questions at the end. So one of the key things about scaling is realizing that as you're using these systems and as you're growing, the build system itself is a critical business function, and you should be running it like you're running any other aspect of your business. And a couple of years ago, we didn't have any metrics on our build systems, and so one of the things that was key for me is like, hey, I know that people are really pissed off that build times are long, but how long are they, and like what are they changing or not? And so we basically we have people that are responsible for maintaining an SLA on the build systems, and they have a very heavy hammer, the ability to change process and who can commit if they need to, because we have to solve for making everyone as a whole productive, sometimes at the expense of an individual. And so we have alerting, we have graphs that are checking things, and we report on this this actually gets reported in the top level business meeting about how the build systems are running and what the availability is. So run them as if they're critical business functions, because they are. I'm going to talk about some of the other aspects that we use continuous deployment. And if you're again from the lean startup, I wanted to. There's a lot of emphasis on customer testing and A/B testing, and continuous deployment actually ties in really nicely with this. And I kind of want to go with sort of the explanation here. So we talked about how we do all of our work on the trunk. We don't actually work on the branches. And the way this would actually look in code is something like this. You do all of your branching actually in the code. So up here, I have what I'm calling as an experiment, which is for, I'm basically building code that's not ready to go out to customers yet, but because it's a brand new feature. So I want to add something. I name my experiment. I set my initial rollout to 0% of the customers, and I say that when I do actually release this experiment, I want 50% of the customers to see an enhanced version. And this is just a helper function, no one would actually have this, but the basic code here is, if the user should see this test feature, then you show the experiment or the test code, this is where all my new code's being written. Otherwise, you just show, if you're basically maybe replacing something, what was previously there or nothing. And the thing about this is the get branch for customer. What this does is, whenever a customer hits this, if they're not in the experiment already, it assigns them permanently to which part of that experiment they should be in. So every time that this routine gets called, that customer will see the exact same results. So you don't log in and see a button one day and not see the button the next day. So that's how all of the code is written. And we were asking about how, is it easy to split things out into a couple hundred lines of code or not anything? This is how it works. And this ties in really nicely to this system. And this is on our production cluster, and I've sort of blurred some of these out I trust you guys, but there's other people. And that tag that I set, which is my experiment name, now this is now available to everybody in the company. In practice, engineers and product owners kind of use this page the most, but you can see like this is rolled out to 0% of the users, and this is either closed or not. And I can roll this out incrementally. One of the things we do while we're developing a feature is we roll it out to QA and admin only, which basically means this is a feature, the only people that will ever see this are QA and admin. We also have the ability to add individual users to it, so we can say like, hey, I want Bob to see this feature, and we can do that. But now, my code is behind this system, and I can test it and only have the users that I want to be experiencing it. So the nice thing about this is, well, my feature's done, let's roll this out. Well, let's bump it out to 5% of the people and see if my feature's even good or not. Because rather than doing a 100% rollout, I'll incrementally roll it out. So you'll see a lot of emails in our company about this feature is live to this percentage of customers. And then over the next few days, you'll see it roll out depending on the results that people are getting. And so this is where you control the participants, and this is where you close things. And in practice, one of the other things that's nice about this system is when we close, we actually have a page that lists experiments that were closed, but the code still exists. So that we have an easy way of doing housekeeping, because you need to go through afterwards and say, this code isn't being used, we've closed the experiment, get rid of the code. Don't leave it in the code base, it comes with a price. If you're a pack rat with code, it's a bad thing.
I'm wondering how this system interrelates with the integration system. How do unit tests test the various branches?
So the question is, how does the unit test the various branches? So you'll actually have usually code that's actually testing specifically within the branch of the new feature. So it's you can force it to take a particular branch if you need to, but if you would probably test that more as a unit depending on the feature that you're writing. And then how this ties into the A/B testing in our company is that same tag that we use now for the experiment. This is I can now run. This is basically stuff that's all kind of important to us as a business that we don't share publicly, evidently. But I can now look at my control group versus the code that I just wrote, my experiment group, and this is automatically built in. And one of the nice things about this is it makes it everyone in the company has access to this. But it's very simple to see, like, okay, this wasn't so good about my code. This is kind of cool about my code, and statistically, this means nothing. So this all ties in together in one nice package, and then this is something that, once it's rolled out, typically, engineers do look at it, but this is where product owners are very interested because they can track and see how this is affecting their aspect of the business. And last thing I'll kind of go over here is one of the things that we ended up changing is we've been kind of doing sort of a Scrum variety for the last couple of years, and when we started kind of getting a little more formal about Scrum, we kind of did the sprints are supposed to be a certain amount of time. We try to lock them down. After a couple of weeks, we decided that doesn't really work. We have enough things come up that it was better to create interrupt lanes and stuff. But we recently just questioned something that was kind of silly. So in sort of the perfect sprint, you have this sort of idea of a burn down, and you start off here with the work, and this is sort of like, if things were to go perfectly on the day that you've committed to sort of your customer release, you've burned down perfectly. So in practice, I've heard, probably not where you work, but sometimes this happens, where stuff has just come up, and frankly, I mean, to be honest, if you're actually hitting that, then everyone's sandbagging, because statistically you should be over and under sometimes. So anyway, but what we found out is, or we thought is like this creates a lot of things that the desire is to drop it or push it into the next sprint, but you want to get to this customer shipping deliverable. And a lot of times the stuff that gets moved to the end of the sprint is maybe some little outstanding issues, bugs, maybe the feature's not completely complete. Refactoring is always very easy to let go of and say, oh, well, the customer can see it, so don't worry about the refactoring. But these are all things that you actually want to be in the sprint. And so I realized, particularly at IMVU, we don't have a lot of external facing milestones. Like we don't do a bunch of marketing campaigns where Super Bowl's coming up and we've got the football promo coming on and stuff like that. Occasionally we do. I mean, but more often than not, it's not that critical. And the other thing is, I realized that most companies that have this, like, well, we have to be ready to release on this date, they have a release cycle that's their release cycle. That's why they have to be ready. When we miss this, the next train leaves in 15 minutes. It's sort of not that big of a deal. So one of the things that we changed is, and we're doing an experiment right now where we're doing this. Some teams are doing this and some aren't. But we just said, well, you know what? Let's understand why we're having this. Like we want to understand what causes the overage in case there's actually a problem. But just let it happen. Like all this was stuff that we thought was important that should be done. Like let's just do it and work on figuring out why estimates are low. But let's finish the sprints and move on. There's no loss here. There's no overhead. We didn't miss anything. It gets out to customers exactly when it was done when we thought it should make it out to customers. So anyway, just kind of in closing here, this is really shortening your release cycle. So you're spending your time in the learning phase, basically shortening your build. It really allows you to focus on what's actually creating customer value and stuff that's actually a little more fun. And one final thing that this system, and actually I think having really good coverage does, this is a really empowering environment for engineers. And we have a thing, so when we hire an engineer, usually on day one, by 2 p.m. is usually about the average, that person has pushed code and is running in our production cluster live in front of customers. So this is literally someone that's never worked at our company, sits down in a chair and has pushed something out. When you realize that you've just walked into something, here's a code base that there's no way that you understand it, that you can make a change and nothing's going to go, it's okay. You start feeling empowered. You start feeling like it's okay to try things. And one of the other things that we have is the concept of Hack Week and Fairy Time. And this is basically telling people that you can build something. If you feel really great that like you're convinced that something's important that's going to be valuable to our customers, go build it. Go ahead and build it. Release it up to, I think right now we can release it to 1% of our customers, put it behind an experiment and get results on it. And this is a system that kind of helps enable you to do that because you can incrementally build something and put it out there and say, I thought this was a cool feature. I put it in front of customers. Here's the results that I got. Or, oops.
Is it like a percentage of time people for that?
Yeah, it's a percentage of time. So we do Hack Weeks about once a quarter, which actually ends up being kind of a Friday to Monday. And during Hack Week, we basically make sure that food's provided for people, anyone that wants to work late. We provide, if people want to come in on the weekends and do stuff, like we basically make sure that if there's any reason that you want to hack, that we create the environment that you can do that in.
But you don't allow it just during regular.
During regular hours, so part of the IMVU culture is we're not what I kind of define as like what you think about like with startups. What I like to think of as like it's very work-life balance is fairly important. You can actually pretty much have a 40-hour work week, come in, be very productive, and we still are able to deliver and everything. And so we usually don't cut into that time. We usually basically say let's block it into the hack weeks. And a lot of people do work in evenings and stuff, and a lot of the stuff that people do in their evenings is stuff that they just thought was cool that they wanted to work on. And sometimes it's directly related to the product feature that they're working on during the day, but other times it'll be like I wanted to see this.
Do you find that engineers who have such ideas, tend to discuss them with product people, or do they just go for it?
So do engineers that have ideas like this, tend to discuss them with product people or tend to go for it? I think it depends on how much of the wow factor they're after and a bunch of other things. So sometimes things are in coordination. There's just certain things that one of the things is a feature eventually has to be adopted by a product owner because someone's going to have to maintain and support it and allocate resources. So we work to make sure that there's a path for people doing that. So in the past we had a bunch of this where someone would build something, put it into the code base, and then product owners would be in a situation where they inherited something that was actually a very big time suck for them. So we had to change how to get that rollout to say it has to meet a certain criteria before someone says, I'm going to pay for it now. And I think that's it. So.
How do you evangelize some of these concepts internally to the 50 engineers? I mean, when it's 5 engineers, it's very easy to share these ideas. So how all this whole deployment system works, and when there are changes to it, when you guys do experiments with teams, and how do you keep that going?
So how do you evangelize this? There's not a whole lot. I mean, it's kind of like evangelizing chocolate. People. Like I said, it's empowering. There's a lot of things. And people, when they work in this environment, going into something where you can't get things in front of customers, it starts irritating you. This has been sitting in my sandbox for a day and a half. I can't get the feedback. I can't get it out. It's not difficult to push from the engineering side to say, should we make this better, or do you want to continue to support it? The challenges have come in sort of the optimization for the individual. So we have had problems where someone makes BuildBot red, they say, I'm going to keep working on BuildBot because it's faster for me to do that. And we did have to do a cultural, we're solving for the overall, not for the individual productivity. So you have to keep that focus. And we do actually have an exception for, after certain hours when BuildBot usage is lower, we do allow people to keep it red if they want to basically keep working on it, but they have to send out an email. Anyone can tell them to no revert immediately. So but basically, if no one else was going to use it, they could use it.
And just one follow-up question to that. So, do you have roles in the company that are just focused on this system, continuous deployment system, and not working on product development or features?
So the question is, do we have roles in the company that are just focused on this? We have. So we've gone through various things. We've had what we used to call the BuildBot sheriff. First we start off with sort of a shared responsibility, and the way I think about shared responsibility with this is sort of like if you live with a bunch of roommates and you kind of have like the agreement that it's everyone's responsibility to do the dishes. You pretty much always have a sink full of dirty dishes. So I found what worked better was to basically point to someone and say, it didn't matter who, but you're responsible, and you have a big hammer. You can do whatever you need to, but you basically need to get everyone into a happy state. And that's worked best. And so we've had that be an alternating role for people. And now we have a team that deals with sort of infrastructure issues. And that team, the primary focus of them, where they spend most of their time, is on BuildBot. There's 2 to 3 people that'll be on that team depending on what the time is and what else we're building. But they maintain a couple of other systems, but sort of once BuildBot gets into a good SLA, they move on to other stuff and kind of come back. But they're always watching it. So that, once it's out of SLA, they pretty much drop whatever else they're on and move on to this.
So the programmers aren't directly hitting the database with SQL statements, right?
The programmers aren't directly hitting the database with the SQL statements.
So they're calling some kind of middleware or procedure.
If I were to write a statement, sort of drop table, it would go out and it would run. I mean, I would call. I mean, it would be unfortunate. It'd be but yeah. I mean, so we do like they're not. We do have a layer that it goes through, but it's not protecting from anything.
So you could potentially have to roll back your entire database.
We could potentially have to roll back our entire database. We could.
I mean, if I leave a where clause out of my replace statement.
Yeah, that's possible. So
update.
Yeah, it's possible. Yeah. Thanks. Now I won't sleep at night. But in practice, so we've been around over 6 years. Hasn't hit yet. One of the other things is, expensive queries are, we have had a couple of things where we've had to restore a table or something. I don't believe it was for that reason,
And I just had a follow-up to, obviously architecture is very important in this. There was the system, because you had this because you started doing continuous deployment in an early phase of development, whether deliberately or just culturally, continuous deployment is part of the architecture of how the code is designed.
So I would push back a little bit because, at least for the first couple of years, the majority of the code was code we didn't write. It was literally open source packages we stuck in there and glued on to each other as fast as possible. There was not, and we weren't at that time thinking about it. And that's actually still, that's still a big part of our code base. I mean, we spend time refactoring this and pulling pieces out, but there's stuff that, just again, from a business perspective, it's very difficult to make the argument that we need to go, here's a feature that is running okay, not high value overall, but we're going to go spend a tremendous amount of effort and give no customer benefit from it. So it sits out there.
So have you considered segmenting build bots? So one item couldn't block everything, it could only block things in its category.
Have we considered segmenting build bots? So that, I would say that we've probably discussed it at some point. I don't remember it being sort of this is what we need to be doing. When I talked about the build isolation, that was largely like one of the big things where I said this is what we need because of the problems we're having. But when we actually kind of got down to it, what we just found is right now the magic number is somewhere around 8-minute builds, and build bots read like everyone's happy. There's just a really big aspect about running the system and how much you invested in it as to are people happy and feeling like it's helping them work or not? And well, that's not scientific. I can't actually put some numbers around, okay, 12 minutes, not so happy, they want some improvements, 8 minutes, they're willing to deal with the red. And so let's keep it at that. And not again, we canceled the build isolation, it just wasn't important. We have a roadmap for other stuff that we want to be doing, but we probably won't start moving on it until we start seeing more pain points.
And are you seeing third-party tools come up that assist, because a lot of this was internally developed?
Yeah, the third-party tools, I haven't heard of a lot. A lot of people ask about us open sourcing certain things. A lot of this is, I'm sure that if we took like the approach that we wanted to make a generic system, that it would probably be a way to do this. I mean, maybe if someone's got a company out there that they're trying to figure out what to do, you might want to look at this. But ours is was pretty much built for a specific function at our company. And so the way it reaches in and touches things was sort of, it works for us, but anyone else, and besides, like I said, some of the scripts are in Perl, so.
So, Brett, we've gone past an hour and a half, so maybe one more question, and there'll be time afterwards for networking and follow-up.
Thank you.
Great.
One more question.
So anyone hasn't asked a question yet? You haven't asked a question yet?
What are the pieces you had to build internally?
Everything. As far as the build servers weren't. So we grabbed BuildBot. We've done some customizations and such to it, but a lot of the stuff that we had to build is the actual deployments of the cluster. The cluster immune system, which is really the thing that really saves you and is really one of the harder things to get right. We had to do that sort of. There wasn't anything that we could grab. But it was, again, a pretty incremental process. Sort of, this broke, our site went down. How do we monitor that and track it? I'm trying to think of some of the others. There's some custom scripts on the. There's a tremendous amount of commit hooks and stuff like that, but that's just commit hooks that integrate into an established SVN system. So I think the deploy scripts, all of them were kind of hand rolled. All right. Well, thank you, and I'm standing continuing here.